Okay, in this video we'll be looking at trigonometry. Trigonometry is another branch of maths which deals with the solution of triangles. It involves finding the length of a side, finding for an angle, and finding for area. Area will be mostly for measurement. With trigonometry, there are two types of triangles we will look at. Firstly, right angle triangle. We can use Pythagoras theorem or the trigonometric ratios to solve questions on right angle triangle. And with non-right angle triangle, we can use cosine rule or sine rule. In this video, we'll focus on right angle triangle. Good. So the first thing we'll look on the right angle triangle, the trigs ratio. The three trigonometric ratios are sine, which is abbreviated as SIN. We don't say sin, even though it's spelled as sin, we say sine. So sine is equals to opposite over hypotenuse. Cosine is equals to adjacent over hypotenuse. Tangent is equals to opposite over adjacent. To summarize the ratio, sine theta, theta is a Greek letter. The theta represent, some persons say theta, it represents the angle, right? So whether it's 40 degrees, 60 degrees, so sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, tan theta equals to opposite over adjacent. Sometimes it might be confusing to remember which one is opposite over hypotenuse, so we can use a popular saying, SOHCAHTOA. Right? SOHCAHTOA means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. They have some other acronyms or things that people use. I think there's another one as some old horse can always hear their owner's approach. But I prefer to use SOHCAHTOA. It's the most popular one out there. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay, before we go into any problem, first of all, we need to know how to label a right angle triangle. So here we have some right angle triangle. A right angle triangle is a triangle where one angle is exactly 90 degrees. And we can use this little symbol to represent the 90 degrees. Good, so here we are given some triangles. And we have three popular Greek letters that is used to represent angle. We can use any letter, we can use X, Y, but mostly we use Greek letter. This one is theta, alpha, beta. So you should be familiar with this. Again, we can use any letter or any symbol to represent the angle, but these are the three important ones. Like in algebra, we use mostly X and Y. In trigonometry, we'll use theta and theta, alpha, beta. Good, so let us label triangle. The longest side is known as the hypotenuse. So here is the longest side of this triangle. So I will label it as the hypotenuse. HYP for short, hypotenuse. Sometimes it's hard to tell which side of the triangle is the hypotenuse. Sometimes two sides might look almost the same. So whenever you have problem into figuring out which side is the longest side, the hypotenuse always be opposite the 90 degrees. Good, so that's another way to determine. So since we find the hypotenuse, the other two sides depends on the angle that is given. So since we are given this angle, here will be the opposite side. And here will be the adjacent. Good. So here will be the hypotenuse. It's opposite the 90 degrees angle. Here is the angle given. So here will be the opposite side. And therefore here will be the adjacent. We abbreviate it as ADJ, OPP for opposite, HYP for hypotenuse. Good. Here again will be the hypotenuse. It is opposite the 90 degrees angle. Since we are given this angle, here will be the opposite side. And here will be the adjacent side. So the opposite and adjacent side depends on the angle that is given in the question. In this case, this will be the hypotenuse. opposite the 90 degrees. Here is the angle given, so therefore here will be the opposite side, and here the adjacent. Good. This is the hypotenuse, the angle given there as beta. Here will be the opposite side, here will be the adjacent side. Final question. This is our hypotenuse. Here will be the opposite side, here will be the adjacent side. Good. So before working any question on right angle triangle, you should be able to label the sides. And if you can label the side correctly, we can able to use the ratio, because sine theta say opposite over hypotenuse. Cos is adjacent over hypotenuse. So we need to understand what is the opposite side, what is the hypotenuse, what is the adjacent side. Alright, we'll move on. Now we'll focus on finding the length of a side. Okay, the camera is a little blur. Good. Finding the length of a side. For us to find the length of a side of a right angle triangle, the condition, this is what must be given, or this is what we should know before we can go ahead finding the length of a side. The triangle must be a right angle triangle. The next condition, one angle and a side must be given. So these are the two conditions, and if you have these two conditions, if these two conditions are met, we can able to use trigonometric ratios. So what I'll do, we want to find the length of a side. What I'll do, I'll write SOHCAHTOA here, so this can guide us. And it's very important, every time you work some question, you can write SOHCAHTOA so that you can remember the three ratios. Good. Find the length of AB. So the first thing I'll do, I will label a triangle. Here will be the hypotenuse. So the hypotenuse is equals to 16. Here will be the opposite side, and here will be the adjacent side. Good. So the question asks us to find the length of AB. So we want to find for the opposite side. The opposite side is not given. We are given the hypotenuse. But since we want to find for the opposite side and we are given the hypotenuse, now let us correspond which ratio will go with opposite and hypotenuse. If you look at it, sine is opposite over hypotenuse. So I'll write sine theta will equals the opposite over hypotenuse. So the first step, we label our triangle. The second step, we determine which ratio to use. And that is based on the side that is given and the side that we want to find. But since we are given a hypotenuse and we want to find for AB, which is the opposite side, so opposite and hypotenuse goes with sine. Good. So we write our ratio. Now we write sine theta will be the angle that is given, which is 30, equals to the opposite, which is AB, over the hypotenuse, which is 16. Good. Since this is a fraction, we can make this as a fraction by putting it over 1. And now we can cross multiply. So AB will multiply by 1, 16 will multiply by sine 30. Anything multiplied by 1 will give you back the same thing. Let's say we have 10 times 1 will give us 10, 5 times 1, so AB times 1 will give us AB. Now we'll have 16 multiplied by sine 30. Okay, we are almost finished. The calculator will do the job for us. Whenever we are using our scientific calculator, we need to ensure that our calculator is in degree mode. Okay, let's see how this will work. Okay, my calculator is not looking too nice, so we have 16 times sine 30 will give us, it's not showing too bright, that will give us 8. So our answer will be 8, and in this case it will be cm. So all you need to do with your calculator, let me see if it will show clear now. 16 times sine 30 give us 8. Good. That's the first problem. The second problem, we want to find the length of PR to 1 dp, 1 decimal place. First thing, I'll label my triangle. Here's the hypotenuse. Here will be the opposite side. So the opposite is actually equals to 9. Here's the adjacent side. Good. So we want to find for PR, which is the PR is the hypotenuse, and we are given the opposite side. So we want to find for PR the hypotenuse, and we are given the opposite side. So we are dealing with opposite and hypotenuse. Again, we'll use sine. So sine theta will equal the opposite over hypotenuse. Sine theta, theta in this case will be 42. Opposite is 9 over the hypotenuse, which we like to find, which is PR. So we have PR. Now we make this as a fraction and we cross multiply. In this case, PR will multiply by sine, PR times sine 42, and 9 times 1 will give us 9. Good. In algebra, we understand if we are multiplying on one side, if we take this on the other side, it will divide. But since we want to find for PR, sine 42 is multiplying here. We take it across, we'll divide, so PR will equal to 9. Whatever is on this side, we need to write it first, divided by sine 42. We can use a fraction to show our division, so PR equals to, so with our calculator, we enter 9 divided by sine 42. Whatever is on top, we need to enter that first. So 9 divided by sine 42 will give us 13.5 if we round off to 1 decimal place. 13.5 meters. Good. So here, it's not showing too clear, but our answer on the calculator is 13.45. And if you want to write it to 1 decimal place, we always look at the second number. And if that number is 5 and above, we add 1 there. Or if it's less than 5, we don't need to add any. Good. Next problem. First thing, I label hypotenuse. Here will be the opposite side. Here's the adjacent side. Good. So what is given? We want to find the length of EF, so we want to find for the adjacent side, and the hypotenuse is given. Adjacent hypotenuse, we'll use cos. So what I'll do, I write cos theta will equals to adjacent over the hypotenuse. Good. Cos theta, theta in this case will be 50, equals to the adjacent, which we like to find, which is EF over 15. Since this is a fraction, we make this as a fraction, and now we cross multiply. EF times 1 will give us EF, and now 15 times cos 50. If you like, you can write cos 50 first and then times it by 15. It wouldn't change the answer. So EF, now with our scientific calculator, we'll enter, let me see if this one will show. So 15 times cos 50. So all you need to do is enter 15 times it by cos 50. And you'll get the answer. Okay, not showing too clear, but the answer is 9.6. So our answer is 9.6 cm. Alright, let us move on to the next problem. Find the length of x to 2 decimal place. In this question, we like to write our answer to 2 decimal place. So I will label, here's my hypotenuse, here's the opposite side, here's the adjacent side. So we need to find x, which is the adjacent, and we are given the opposite. So we need to find the adjacent.